Hey there, science fans. Let's talk about something truly brilliant. The sun. Our sun is not just a bright light in the sky. Oh no, it's a gigantic, magnificent star. It's like a massive nuclear reactor, billions of miles away. It's constantly fusing atoms and sending out incredible amounts of energy. This energy travels through space as light and heat. We call this wonderful gift solar energy. It's what makes our planet warm and full of life. So, what is solar power then? Well, it's all about us clever humans learning to catch that sunlight. We've figured out ways to harness the sun's energy. We can turn it into electricity to power our homes and gadgets, or we can use its heat directly for things like warming water. Solar power is basically converting sunshine into usable power. It's a clean, smart way to get the energy we need every single day. Pretty neat, right? Now, why is solar power so important, you ask? Consider this. The fuels we've been using, like coal and oil, are called fossil fuels. They took millions of years to form. And guess what? We're using them up really, really fast. Plus, burning fossil fuels pollutes our air and changes our climate. Solar power, on the other hand, is renewable. That means it won't run out. The sun will keep shining for billions of years. And here's the really cool part. Solar power is for everyone. Your own house can have solar panels on the roof. Big factories and businesses can use giant solar farms. Even tiny things like your pocket calculator or garden lights can be powered by the sun. Solar power is a super important tool. It's helping us build a cleaner, brighter future for our amazing planet Earth. Let's explore how it works. All right, let's zoom in on how we turn sunlight into electricity. One of the main ways is using something called photovoltaic cells. That's a big word. So let's just call them PV cells. You've probably seen them. They are the dark, shiny squares that make up solar panels. These PV cells are the real heroes of solar electricity. They perform a kind of science magic, turning sunlight directly into electrical power. It's all about physics, folks. How do these PV cells perform their amazing trick? Well, sunlight isn't just light, it's made of tiny energy packets called photons. Imagine these photons as little messengers from the sun, zipping through space. When these photons strike a PV cell, they hit atoms inside the cell. This impact can be strong enough to knock electrons loose from those atoms. These freed electrons are just itching to move, to flow, and that flow is key. Now, PV cells aren't made of just any old material. They're typically made from silicon, which is a semiconductor. Think of it as a special kind of material that can be nudged to conduct electricity. The silicon in a PV cell is treated to create an electric field. This field acts like a one-way street or maybe a super-fast slide for electrons. It pushes all those freed electrons to move in a specific direction. It's a very organized electron dance. And guess what happens when all those electrons start flowing in the same direction? That's right, you get an electric current. This is electricity, my friends. Specifically, it's direct current or DC electricity. Each tiny PV cell makes a little bit of electricity. But when you put lots of them together in a solar panel, they make more. And when you connect many panels, you can generate a whole lot of power. Science! It's electrifying. So you've got your solar panels catching those sunbeams. But a full solar PV system for your home or business is more than just the panels. It's a whole team of components, all working together like a well-oiled machine, or maybe a well-sunned machine. First, of course, are the solar panels themselves, the stars of the show. They're usually mounted on your roof or on racks on the ground, always trying to get the best view of the sun. Next up in the solar squad is a very important device called an inverter. Solar panels, as we learned, produce DC or direct current electricity, but most of the appliances in our homes, like your TV or your refrigerator, run on AC or alternating current electricity. The inverter is the clever box that takes the DC electricity from the panels and changes it into AC electricity that your home can use. It's a crucial translator for your power. Then you have the racking and mounting systems. These are the unsung heroes. They are the strong, sturdy structures that hold your solar panels securely in place. They have to be tough enough to withstand wind, rain, snow, and whatever else Mother Nature throws at them. They also help angle the panels correctly. This ensures they capture the maximum amount of sunlight throughout the day. Proper positioning is key for peak performance. Finally, Many PV systems also include meters and sometimes batteries. The meters are there to keep track of things. They measure how much electricity your solar panels are producing. They also measure how much electricity you are using from the grid or sending back to it. Batteries, which are becoming super popular, store any extra solar energy you generate so you can use that solar power even when the sun's not shining, like at night. Smart. Now, not everyone uses solar power in exactly the same way. There are different types of solar system setups, so let's check them out. The most common type for homes and businesses is called a grid-tied system. This means your solar panel system is connected to the main electricity grid. The grid is that big network of power lines that brings electricity to most communities. It's like being part of a giant power-sharing club. With a grid-tied system, when your panels are making electricity, your home uses that solar power first. If your panels produce more electricity than you need, say on a really sunny afternoon, that extra power can flow out onto the grid. Your utility company might even give you credit for it. This is called net metering. Then if you need more power than your panels are making, like at night, you just pull it from the grid as usual. It's seamless. Then there are off-grid systems. These are for people who want to be completely independent of the utility grid. Think of a remote cabin deep in the woods, or a boat or an RV exploring the great outdoors. Off-grid systems are not connected to any power lines. Because of this, they absolutely must have batteries. The batteries store the solar energy collected during the day. This stored energy is then used to power everything when the sun goes down or on cloudy days. And finally, there's a setup that combines the best of both, the hybrid solar system. A hybrid system is connected to the utility grid, just like a grid-tied system, but it also includes batteries for energy storage. This gives you amazing flexibility. You can store your excess solar power in your batteries for later use. This means you rely less on the grid, and if the grid ever goes down, your batteries can provide backup power. It's like having your own mini power plant. Section 5, Sunbeams under a magnifying glass, concentrated solar power, CSP, explained. So far, we've talked a lot about photovoltaic or PV, panels that turn sunlight directly into electricity. But hold on, there's another fascinating way to harness the sun's energy. It's called concentrated solar power, or CSP for short. This technology is usually used for very large-scale power generation. We're talking about big power plants, not typically something you'd put on your roof. It works quite differently from PV panels. How does CSP work its magic? Well, instead of PV cells, CSP systems use mirrors. Lots and lots of mirrors, sometimes thousands of them. These mirrors, called heliostats or troughs, are designed to track the sun. They meticulously focus vast amounts of sunlight onto a very small area, a receiver. It's like using a giant magnifying glass to concentrate the sun's rays. This concentrated sunlight generates incredibly intense heat. We're talking hundreds, even thousands of degrees. Now, what do they do with all that intense heat? They use it to boil water, or sometimes another fluid like molten salt. When water boils, it creates steam, right? And this high-pressure steam is then used to spin a turbine. A turbine is like a big, high-tech pinwheel. This part is very similar to how traditional power plants like coal or nuclear plants generate electricity. They also use steam to turn turbines. Once the turbine is spinning, it drives a generator, and the generator is what actually produces the electricity. So, CSP uses sunlight to create heat. The heat makes steam. The steam turns a turbine, and the turbine spins a generator to make power. One really cool thing about some CSP plants is that they can store the heat. They often use molten salt to store this thermal energy. This means they can keep making electricity even after the sun has set. How about that? So, we've seen how solar power works, but why is everyone getting so excited about it? What are the big advantages of going solar? Well, first and foremost, solar energy is renewable. Think about it. The sun has been shining for about 4.5 billion years. And scientists predict it will keep on shining for another 5 billion years or so. That means we have a virtually limitless supply of solar energy. We will never ever run out of sunshine. That's a big win for our planet. Another huge benefit is that solar power is clean energy. When solar panels make electricity, they don't burn any fuel, so they don't release harmful greenhouse gases like carbon dioxide into our atmosphere. This is incredibly important for fighting climate change and keeping our planet healthy. Using more solar power means cleaner air for us to breathe. It means a healthier environment for plants, animals, and for us humans too. Go Earth! Let's talk about your wallet. Using solar power can actually save you money on your electricity bills. Yes, there's an upfront cost to install a solar system, but once it's up and running, the fuel, the sunlight, is completely free. Over the years, the savings on your energy bills can add up significantly. In many cases, the system will pay for itself over time, and after that, it's just free electricity from the sun. That's what I call smart economics. And there's more. The solar industry creates jobs, lots of them, from manufacturing the panels and components to installing the systems to research and development of new solar technologies. It's a growing field that boosts our economy. Plus, solar panels are generally very low maintenance. They operate silently, so no noisy generators, and they can increase the value of your home. So many good reasons to embrace the power of the sun. Now, as much as I love solar power, and I really do, it's important to be scientific about it, and that means looking at all sides. Solar energy is fantastic, but it does come with a few challenges. We need to be aware of them so we can work on solutions. One of the biggest ones is something called intermittency. That just means the sun doesn't shine all the time. What happens at night or on very cloudy, stormy days? Power output can vary. Another factor to consider is the initial cost. Buying and installing a solar panel system can be a significant investment up front. The panels, the inverter, the mounting hardware, the installation labor, it all adds up. The good news is that solar prices have been falling dramatically over the years, and they continue to get more affordable. Plus, there are often tax credits and rebates available to help reduce that initial pinch on your pocketbook. Solar panels also need space. To generate a useful amount of electricity, you need a decent amount of surface area for the panels. If you have a very small roof, or if your roof is heavily shaded by trees or tall buildings, it might be tricky to install an effective system. Large-scale solar farms, which generate power for many people, also require significant amounts of land. We need to be thoughtful about where these farms are located to minimize environmental impact. Finally, let's think about what goes into making solar panels. The manufacturing process itself uses energy, and it involves various materials, some of which can be hazardous if not handled properly. Recycling old solar panels is also a challenge that the industry is actively working on. We want the entire life cycle of solar technology to be as green as possible. Science is all about identifying problems and then, you guessed it, finding solutions. And we are. Get ready for some exciting news, folks. The world of solar technology is not standing still, not even for a second. Scientists and engineers all over the globe are working tirelessly. They are constantly coming up with brilliant new ideas to make solar power even better. More efficient, more affordable, more versatile, the future of solar is looking brighter than ever. It's a super exciting time for solar innovation. Innovation, I love that word. One area that's buzzing with activity is the development of new types of solar cells. For decades, silicon has been the king, but new materials are emerging like perovskites. Perovskite solar cells show amazing promise. They could be cheaper to make, more lightweight, and even flexible. Imagine solar cells that you could print onto surfaces like paper or plastic. Or how about windows that look like normal glass but are actually generating electricity? That's coming. Battery technology is also taking giant leaps forward. This is super important for solar. Better, cheaper, and longer-lasting batteries mean we can store much more of that precious solar energy. This helps a lot with the intermittency problem we talked about. If we can store enough solar power efficiently, we can use it whenever we need it, day or night, rain or shine. That makes solar a truly reliable power source for everyone, everywhere. Power on. So what else does the future hold? We might see solar power integrated into almost everything around us. Think solar-powered roads that charge electric cars as they drive, or solar fibers woven into our clothes to power our gadgets. Some scientists are even working on space-based solar power. This involves collecting huge amounts of sunlight in orbit around Earth and then beaming the energy down to where it's needed. The possibilities are truly out of this world. So, who are the big players making this solar dream a reality around the world? Many countries are stepping up and leading the charge. China, for instance, is a true solar superpower. They manufacture a massive number of the world's solar panels, and they are also installing enormous solar farms at an incredible pace. They see the immense potential of the sun and are investing heavily in it. That's a big commitment to a cleaner future. The United States is also a major contributor to the solar revolution. There's a lot of cutting-edge research and innovation happening here. Many states are actively promoting solar energy through supportive policies and incentives. And let's not forget Australia. With all that sunshine, it's no surprise that Australia has one of the highest rates of rooftop solar installations per capita in the world. Millions of Aussie homes are powered by the sun. Fantastic. Germany was one of the early pioneers in solar energy. They really showed the world that widespread adoption of solar power was possible, even in a country that isn't always sunny. Their commitment helped drive down costs globally. India is another nation that is rapidly expanding its solar capacity, aiming to bring clean power to millions. It's truly becoming a global effort, with countries big and small recognizing the incredible benefits of solar. Teamwork makes the dream work. Ultimately, solar energy is not just an alternative, it's a cornerstone of our sustainable future. It empowers us to combat climate change by reducing our reliance on fossil fuels. It provides us with clean, abundant, and increasingly affordable electricity. As technology continues to improve and costs continue to fall, solar power will become accessible to even more people around the globe. The future, powered by the brilliant, reliable sun, looks incredibly bright. Consider the possibilities.